Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot, and in today's video let's review the analog Baron from Black Square Simulations. The best literally just got better. If you see my review on the analog Bonanza, which is basically the single engine version of the Baron, then you can be sure that there will be quite some interesting stuff in here. The great news comes first straight away as well. Since both aircraft, the Bonanza and the Baron, are so similar to one another, there is a 25% discount available for Bonanza users for those who are interested into the Baron. Okay, now let's have a look at what the Baron offers though. There are two different versions included. One of them is the turbocharged version and the other one is the normally aspirated version. Right now we're sitting in the normally aspirated, and I want to show you the differences in the cockpit between the two, because there are quite some of them. Now, contrary to the Bonanza, the Baron is actually equipped for flight into known icing conditions, as you can see on the leading edges over here, where you can see the de-icing boots all over the leading edges. Also we have a heated windshield and so on. Okay, so looking into the differences in the cockpit, you will find that on the normally aspirated version, the manifold pressure can go to a maximum of around 29.6 inches. Compared to that, you will see that the turbocharged version can actually go all the way up to 40. Other differences are mainly visible down here in the equipment that's fitted to the airplane. The turbocharged version is also equipped with a cabin pressurization system, so you have all the extra gauges for that. And at the same moment, the normally aspirated version is equipped with a pilot oxygen system to enable it to climb higher than flight level 100. The normally aspirated version is really fun to fly because, since it is not a pressurized airplane, you really need to keep your rate of climb and rate of descent under control, while at the same moment it has very powerful engines. So if you just set those engines to climb power and climb at the best rate of climb speed of around 115 knots, then you are going to get immense rate of climbs, like 2,000 or even 3,000 feet a minute. However, since the plane is not pressurized, that would really hurt in your ears. So flying this is quite a bit of fun, since you need to keep an eye on a lot of different things. Also, every single one of the included versions have the hot swappable radio stacks that we are used to from Black Square Simulation. So using the two switches located on the right of the panel over here, we can switch between the GTN 750, which supports both the TDS and the PMS 50, and the GNS 530, which is the standard Asobo working title simulations GNS. And of course we have an option where we have a simple radio comm installed as well, resembling the 1980s era that this airplane was primarily, well, having its golden age. It's still a very good airplane today, don't get me wrong on that. On top of that, we have another option to change the COM to, where we can install a GNS 430 as well, and of course all those options are compatible with one another, so you can switch them around while they're hot. Personally, this is kind of like my favorite setup, with the TDS GTN 750 XI installed and with a normal radio on the number 2 stack. But I'm going to talk you over that later on. Apart from that, we also have the KNS-81 ARNOV computer, on which I've done a separate tutorial already, so do check that out if you haven't yet. And then we have the EDM 760 engine monitor, which is a very interesting device, which I'm going to show you later on in the cruise. So, apart from that, the cockpit will look fairly familiar for those of you who own the the Bonanza already, but those who don't, I'm going to give you a full tour of it in a few moments. But for now, let's switch over to the turbocharged and pressurized Baron to see the differences. Alright, we are sitting in the pressurized Baron now, and you can immediately see a couple of differences in that we have turbocharged engines here, bringing it up to a maximum manifold pressure of 39.5 inches, which is quite a bit of power, as you'll see. And then going down to the instrumentation, we now have a pressure cabin installed in this aircraft, which is why we have a couple of additional gauges available in this plane as well as a couple of associated switches. The interesting thing here, however, is that the Pressurized Baron has a huge limit on the maximum number of cycles that the airframe can take before it has to be phased out if you pressurize it regularly. So flying it pressurized is quite a bit of drawback compared to flying it unpressurized, which is the reason why most flights are actually done without help of the cabin pressurization system. However, for the purpose of today's video, I will of course demonstrate it to you. Apart from that, all of the models feature a very extensive failure system, and I'm going to demonstrate you one of those later on in this video. And apart from that, let's head right into the plane and take it flying for now, and then I'm going to show you a little bit of how to fly the Baron. The first things first though, we do not have any custom refueling dialog, so we need to use the default simulator dialog here. So let's just go ahead, give us a full fuel tank, including the tip tanks, and we are just going to be pilot and co-pilots. Pretty much us being the one interested in getting it, and of course we have a sales guy to the right of us who's going to show us around the airplane. Alright, so in terms of the setup of our avionics, this would be my default avionics stack with the GTN 750 and the KX 155 radio as radio number 2. And also here we can swap it around as we like it. And for the purpose of today's video, I think I'm just going to use 2 normal radios. And then we'll use the RNAV computer to navigate around in order to show you that RNAV computer in action a little bit more. Okay, so since that is our setup done, we have some extensive checklists coming with the product in order to help starting it up. And these are going to guide you all around. But since I've flown the plane for a little bit in the last couple of days, since I've had it for about a week, at the point where I'm doing this video, you can see I've flown it around 7.5 hours in the pressurized version, another 2.5 in the non-pressurized, so I have about 10 hours in the airplane right now. Okay, let's go ahead and start it up. Beacon on. We check that other than the beacon, pretty much all the switches are off and all the levers are fully forward, except for the park and brake. The flaps are up and the cabin pressure is in the dump and the door seals are non-pressurized. Prop levers full forward, mixture full forward, and the thrust levers remain in idle, cowl flaps open and the trims are set neutral, fuel tank selectors on. Apart from that, the circuit breakers are all in, and every single one of them does work. So as you can see over here, if we pull that circuit breaker, then it's going to show this little red part below it. And of course, all those circuit breakers are tied to the correct buses. And over here, the right set of circuit breakers is running fine as well. Okay, so let's go ahead and start it up. Batteries on, and now we are quickly going to check the function of the fuel pumps. You heard them illuminate in the back over there. The same, by the way, goes, for example, for the combustion heater that is installed on this airplane, so have a listen to this. Basically, the Baron is fitted with a combustion heater that is located inside the nose of the plane. So you can imagine this like a little oven that you have in there that is able to produce heat for you in order to heat up the cabin. That's the case on a lot of multi-engine aircraft, by the way. So let's call it nothing special. But it is the first time I actually see something like this simulated in a flight simulator aircraft. But please correct me if I'm wrong there, which I might very well be. Okay, so let's go ahead and actually start the airplane up. We've got 3 different sets of engine start checklists, and we've got to carefully pick the one that we want to use. We've got engine start cold, engine start hot, and engine start flooded. Now, cold and hot does not refer to the different temperature environments, but rather it refers to the state of the engine. Basically, you want to use the cold checklist if the cylinder head temperature here is reading below 50. And the hot start checklist is basically used when you have already flown the plane and have just headed out for a bit. And the flooded checklist is in case you mishandle your engine startup and you flood the cylinders. This is how you can get the plane back to working correctly. Apart from that, you can see there's a lot of non-normal checklists as well, but we are going to deal with those later on in this video. So for now, let's go ahead with the engine start cold. So beacon is on, masters are on, then prop lever is full forward, mixture full forward and throttles full forward. Run the boost pumps, check that we have fuel flow with the boost pumps in high, more than 3 gallons. And we're gonna do this for a couple seconds. The checklist says 2 to 3 seconds. Personally, I found the startup to work quite a bit better if we run it for a bit longer. But we've got to be careful not to flood the engines there. Okay, so with that done, the throttles can be returned to the correct position. We're clear on the right, clear on the left, starting engine number 2. Okay, that's a good start on the number 2 engine. Note that you do need to hold the switch into the start position yourself. You can't just scroll it into it. So, 1000 RPMs, we've got oil pressure, oil temperature is rising, and that's a good start on number 2. Starting number 1. Okay, that's the number 1 running. Oil pressure is there, oil temperature is rising. Okay, that's a good start on engine number 1, also running it at 1000 RPMs, perfect. Okay then, after start procedures. Avionics master on, the temperature is above 10, so we can leave our anti-icing devices off there. Quick check of the annunciators, and be aware that all the annunciators in this airplane can actually fail. So not only the systems can fail, but also the annunciators of those systems can fail. Which is quite cool, actually. We've got all the failure simulations covered in the weather radar display, so let's have a quick look at that. First of all, you can see how I'm treating my engines, and you can see that I'm not treating them too well. So, over the time, your engines are going to wear out, and you can see I've got my left engine at 78%, the right engine at 65%, and you will actually see this in the performance of the engines in flight and on the ground. So once you get them too low, you might want to repair your engines. Also, we can replenish our oxygen over here, reset all failures, and then up here in the failure page we can actually activate like random failures, scheduled failures. We can set the global failure rate, which is at 1x at the moment, so realistic. Then we've got a view of our active failures, we can reset them as required, and then of course we can go to detailed settings where we can basically arm any failure manually. And on the right here you can see the mean time between failures in hours, so you're going to experience an engine failure every 10,000 hours roundabout. Of course that's not every 10,000 hours exactly, but with a probability of 1 in 10,000 you're going to have an engine failure. Okay, for now, return the weather radar to the standby function. Start up the transponder, and down here we have the cabin temperature indication, which is something really interesting to control. So, right now on the ground I'm just keeping the cabin heater turned off, but if it's especially hot or especially cold outside, you will actually have to manually control the heat of your cabin, and you've got 2 little lights installed up here as well that are going to give you indication if it's especially hot or especially cold in the cabin. Okay, so on the ground, lean those engines, otherwise they are very prone to spark plug fouling, which is simulated correctly. And with that, we are pretty much ready to go. So I will apologize in advance to this gentleman over here with his pushback tug. But I am about to run you over because, well, you just shouldn't park in front of an airplane with running engines, okay? Okay then. Taxi light on, park brake off. When the plane is heavy, it will not really start taxiing on its own. You can see it right now, that it's creeping forward very slowly, but then keep in mind we still have room for another 4 passengers and some cargo. On the ground, throttle settings in the region between 1000 and 1200 RPMs are pretty much the norm, so as you can see, The plane taxis really nicely with those. So let's head over to runway 26 here at Egelsbach, and then we'll depart to the south, climb a little bit to a higher altitude to see what kind of performance this airplane can achieve, and then finally we are going to get it back, maybe do a couple touch and goes at Mannheim first to see how the airplane handles, and then we're going to fly it back towards Egelsbach eventually. Also, including a demonstration of an engine failure there, since this is a multi-engine aircraft, so single engine behavior is definitely going to be of interest for us as well, seeing that this is aimed to be a study level simulation. The weather at the moment, as you can see, is not all that good, but I decided to keep it at that because this is an IFR equipped and certified aircraft, so we are probably going to go IFR with it, go above the clouds, and then we'll see about the procedures we are going to fly. Okay, so we are reaching the holding point here. You gotta taxi it slowly. If you slam those brakes while you're going fast, then you will see the airplane reacting properly to it, as you have just seen when the nose just vibrated up and down a little bit, which is exactly what you would experience in a real airplane as well. So really well done there from Black Square. Okay, parking brake is set. Checking the engine gauges, we have cylinder temperature, we have oil temperature above the amber, so we can start our engine run-up. Throttle full forward, we'll start at 1700 RPMs. And the run-up initially is quite similar to the run-up in the analog Bonanza, but there are some additional steps to check the cabin pressurization system, and of course a couple minor variations since this is a multi-engine airplane. So we'll start at about 1700 RPMs. Like this, okay? And we'll start by cycling the propellers. Now when we do so, we want to observe three things. The RPMs dropping to about 1400, then I'm going to increase RPMs again, and that's going to go really fast. At the same time, we're going to get an increase in manifold pressure, and then we want to also observe an increase in oil pressure. This is different to the Bonanza, where you are looking for a decrease. In the Baron, you're looking for an increase. Okay, so let's start with that now. So the props are dropping normally. Now we're going to do that again. This time we watch the manifold pressure, and that is increasing slightly, even though really slightly, but that is all we're looking for. And now we're going to do it a third time, and we're looking for the oil pressure to rise. And as you can see, that is exactly happening. Okay, so that's looking good. Let's go ahead then and check our magnetos. I'm just quickly waiting for the engines to stabilize at 1700 RPMs once again. So, magnetos right. Magnetos left. Nope, that was too far. But as you can see, you put it on time again, and the thing still works. So the engine isn't going to shut down immediately. Here we go, on the left magneto. We're looking for a drop of a maximum of 150 RPMs and a difference between the two of a maximum of 50. So if you look at that, we can see that there is actually a slight difference between the two engines, because they are in a different condition from one another. But that is still within limits, so that is acceptable. Okay. So that's our check of the magnetos. Then we can now go ahead and check the electrical equipment. We're going to start by turning off the left alternator, and you will notice the alternator load dropping on the left side and increasing on the right side, which is what we have. Now we turn off the right, and they both go to 0. Turn on the left, and you can see the load over there. Now we turn on the right once again, and they pretty much even out once again. So let's check our electrical and de-icing equipment now. And every time we flick on a switch over here, we're looking for an increase in the alternator load. So let's check that out. Increase, 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 increase. And when we turn the prop heat, We're also looking for the prop amps to rise over here, which they do. Perfect. So now we're going to check the de-icing boots. So we'll start with the switch in the manual position, and we observe the de-icing pressure rising over here. We're looking for something between 15 and 20 psi. And back and off. It drops again. Now the surface de-ice goes to auto, and it rises once again, and still between the two. And you can see how the boots are working in their standard cycles right now. Okay, perfect. So the anti-icing system is working. Okay, now let's increase towards 2000 RPMs, and now we're going to check the cabin pressurization system. So that is 2000 RPMs, and first things first, we are verifying that the system is indeed switched off with the switches off, so the cabin rate of climb is 0 and the cabin stays where it currently is. Next up, we select the target altitudes down to 1000 feet below our level, turn on the cabin pressurization and the door seals, and now we're going to hit the test button, and you will observe the cabin descending. Like now. Okay, perfect. Then the seals can go off again, and that is pretty much our cabin pressurization system checked. So we are going to return the switch into the first cabin altitude that we aim for. Now, for the initial part of the flight, we are actually going to do a little bit of checking on the airplane. So we will pressurize it. So let's select it up, something in the region of around, let's say 16,000 feet. Alright. And with that, we can now return the engines to standard idle conditions. We're going to do another check of the autopilot system up here. Thereafter, we'll set up the instruments, and then we're ready to go. Okay, so between 1000 and 1200 RPMs. Now let's go ahead and check the autopilot system. First things first, we're going to check that the autopilot actually responds the way it should. So heading select mode is active, autopilot engaged, yoke turns left, flight director goes left. Now we select the heading 30 degrees to the right of our track, flight director goes right, control column goes right. Let's just quickly check that it actually moves across the middle position, which it does. Okay, autopilot disengage works, second press removes the flight director. Now we're going to do that once more, and now I'm moving my hardware yoke all the way to the left. And after a little while, you can see the autopilot is overridden, and we now have manual control again. So both methods of disengaging the autopilot are working. Okay, then let's quickly go ahead, set up our flight instruments. So we're looking for a QNH of 1007 over here. The runway heading is going to be 260. And we're going to take a southbound course of around 190 as we are heading towards Mannheim initially. For the radios, we can use read 12.2, active number 1 and active number 2. We'll also pre-select that on the ANAV computer, since we will be using that for navigation later on. Okay. Then, weather radar on, transponder altitudes, and with that, we are ready to go. So, probe heat always on, strobes on, navs on, landing lights on, and then we are good to go. Okay, park and brake off. Quick last check of our engine instruments, everything is in the greens. Cylinder temperature is rather hot, but that's expected. The cowl flaps are open. Keep in mind, we did a rather lengthy run-up since I did a lot of explanations there, so that's actually quite expected. Okay. So we've got to advance those throttles slowly so that we don't overboost the engines. So let's be careful when we do that. And then flaps remain up. Flight controls are working. Okay, off we go. Take off. Okay, takeoff thrust set, indications normal. We're going to rotate at 80 and climb at 115. V1 rotate. Positive rate of climb, gear up. And just feel that raw power of the airplane climbing up here. So, more than 400 above the ground, throttles down to 2500 RPMs. Then we start the left-hand turn in order not to overshoot the highway that we're going to see over here. We just want to go slightly to the right of that highway, but we don't want to overclimb it. Also maintain below 1500 feet, so that we don't accidentally climb into the controlled airspace of Frankfurt Airport, which is right nearby. Okay. So we're pretty much following that highway southbound right now, which is going to keep us clear of the control zone of Frankfurt Airport as long as we stay below 1,500 feet. Once we're passing the read VOR that we've set active over here, we can climb to 3,500, and that is going to keep us below the controlled airspace. Now, for the purpose of the video, however, we are going to pick up our IFR in a moment and then demonstrate how the airplane climbs. I just want to get clear of Frankfurt Airport here, and the one thing that you are immediately going to notice is just how fast the Baron really is. So I've reduced my manifold pressure quite a bit over here, down to 30, and the RPMs at 2500, and you can see we're doing 200 knots indicated up here. And as we climb up to higher altitudes, we're actually going to get even better rates of climb, even better airspeeds, I meant, of course. So we are expecting something at maximum power and about flight level 200 to the region of 250 knots true airspeed at a decent cruise power setting, providing for a very nice cruise. Right, I would say we are about clear of Frankfurt, so let's increase our thrust. And we will assume that we have picked up our IFR right now on the present heading, climbing to flight level 160. Okay, set. 160 tracked. Let's turn on the cabin pressurization system. So we're stabilized in the climb. We can close our cowl flaps. Just got to keep an eye on the temperatures down here, that they stay within the green band. So let's explore some of the functionality of the autopilot then. We can see that with the present flight conditions, we're doing around about a 2,000 feet a minute climb. So let's pre-select that on the flight director. 2,000, heading select, climb on flight level 160. Okay, and with that pre-selected and the airplane pretty much in trim, autopilot engage, and here we go. One thing to keep an eye on is, due to the huge rate of climb that this airplane can do, we really got to monitor our cabin pressurization system in order not to exceed the maximum differential pressure. I'm actually going to increase the cabin rate of climb a little bit here, because we want to get up to altitude quickly. Otherwise, we might have to reduce our rate of climb here a little bit. But as you can see, the plane is now climbing nicely. We're about to enter the clouds, temperatures below 10, so let's turn all the anti-ice on, and I'm also going to turn the defrosters on here. And it's getting quite cold in the cabin at 10 degrees, so let's also put the heater on, pull those out a little bit so that we can actually start heating up the cabin. En route climb speed is in the region of around 140 knots, so as you can see we could even climb a little bit faster here, bring it up to, let's say, 2500 RPMs. And here we go. So, weather radar is good. A quick chat about the weather radar, as we are about looking at it right now anyway. And the weather radar we have in here is the standard Asobo radar. At the time I'm recording this, this is still the 2D top-down view, so what you see over here basically ignores the tilt angle of the weather that we've set up there, but it is a 2D view. So if we go into the vertical profile view, then we can get something vertical, but what we cannot get at the moment is what I would be looking for the most, that is the ability to actually view the weather properly by changing the antenna tilt angle. But it is something to start with, so I am quite happy that we have it, rather than not having it. Okay, let's do 2,000 feet a minute once again, and we're about approaching flight level 90 already. Let's go ahead and set the altimeters to standard. Here we go, standard set once and standard set twice. Cabin temperature is looking good now at 21 degrees centigrade, so we can remove a little bit of the cabin heat there. Lights can go off, and passing flight level 100. Looking down at the cabin altitude, that is looking good, but you can see how the differential pressure is slowly but steadily going towards the maximum. So we've got to keep an eye on that. Maybe just make the cabin climb a little bit higher here. Basically, I found that if you set the target altitude exactly to the cruise level, you will end up very slightly in the red band of the cabin differential pressure indicator. So if you set it a little bit higher, then that is absolutely fine. If you want to fly the plane up to the maximum altitude, however, then you will find that the plane is certified for flight level 250. However, you are only going to achieve that when you take the cabin altitude up to 12,000 feet. So for European operation, that is not permitted. And with the cabin altitude limited to 10,000 feet, if you're looking at this, then 10,000 basically gives you flight level 220 as a maximum achievable level here. However, we don't want to go that high today. Let's take it somewhere in the region 20,000 feet. And that should be all we need in order to demonstrate the performance capabilities of this airplane. So 20,000 is set. So let's have a quick look at the engine instruments as we're on it. And looking at this, you will probably have noticed that little turning thing in the middle down there. Now, this actually tells us which engine is producing more power. So as this is turning towards the right-hand engine is currently producing a little bit more power. So in order to equalize that, here's what we can do. We can either reduce the throttle on the left side, or we could reduce the RPMs. Now we want to stay at full throttle, so let's just about equalize the RPMs. And I'm slowly going to pull those back until the thing is no longer rotating. Of course, we could simply use the propeller synchronizer as well, which is going to do the same job, but I want to show you how this is actually working. Okay, so reducing the propeller slightly, and it's almost impossible to see here because it's just very, very small inputs that we're making. But you can see how I can easily influence this thing. So now it's pretty much hardly rotating at all. So if I now turn on the propeller sync button that we see down here, like this, you will see that the airplane will very slowly eliminate the difference between the two sides. And here we go. Now it's not turning anymore. Now both engines are producing pretty much the same power. Okay, another look at the cabin pressurization. We are now at the maximum differential, so let's actually get the cabin climb a bit faster. But we don't want to do more than 1,000 RPMs. That is just going to hurt our ears. Okay, and I'll reduce the rate of climb a little bit. And with that, the airplane is already nicely accelerating to a very nice en route climb speed now. Also, we've left the icing conditions, so let's go ahead and switch the de-ice off. I'm going to leave the prop heat on, however, and I'll leave the window defrost on as well, because I'm likely to forget it in the descent again. Cabin temperature is looking good, 23 degrees right now, which is a very nice temperature. Do note that the cabin temperature changes with the external influences. So if we are flying through a cold environment, like we are right now at minus 15 degrees outside, then we are going to need a lot more cabin heating than if we are flying through a warm environment, and of course the other way around as well. Okay, plane is climbing nicely, our differential pressure is under control there, so that's something you need to actively manage, keeping the cabin pressure and the differential pressure under control. This is not as easy as, for example, your Boeing 737 or Airbus A320 is, where you basically just set and forget the numbers. In here you actually need to keep an eye on it, because the airplane's got such a great climb performance. Okay, passing 18,000, that means we have another 2,000 to go. So let's explore a couple of the functionality of the ANAV computer as we're climbing. Our flight is taking us down to Mannheim Airport, and looking at the charts, we can see that Mannheim Airport is basically defined by a radial and a distance from some VORs. So if we look at the approach chart, we can find that reporting point Sierra is defined as radial 351 from Kilo Romeo Hotel VOR at 25 miles, and waypoint Kilo is defined as radial 175, 14 miles from Romeo India Delta VOR. Now that is the one that we have been using previously, so let's go ahead and preset our ANAV computer to guide us towards the reporting point Kilo. And we can do that by tuning the frequency, 12.2. Then we are going to tune the radial, so click data, go to radial, and then we have 175. Like this. You can change the first two numbers with a large button and the last one with a small one. And then data once again, and we are looking for a distance of 14 miles. Like this. Okay, if we now select the HSI source to ANAV, the computer is basically working at still like a normal VOR, as long as it is selected to ANAV mode up here. However, that VOR is basically placed at the reporting point Kilo that we have just defined by the distance and the radial. So, very nice little thing there. We're approaching flight level 200, very good. And looking at the cabin differential, that is just about maximum. The cabin has roughly stopped climbing as it reached its, or as it is approaching its target of 9,000 feet. Very nice. So the autopilot is now going to level us off over here. You will have noticed that for pretty much the entire climb, our engines remained at maximum manifold pressure that I've selected with the throttles. And I also did not do any leaning yet. Now this is something that is actually a first in Microsoft Flight Simulator, because Black Square Simulations is actually simulating the turbochargers of the plane properly. That means that up to the critical altitude, which in our case is somewhere just above 20,000 feet, the turbochargers are going to be able to maintain the engines at the maximum manifold pressure that we can see up here. So for that reason, we've been able to fly the airplane up like this with pretty much a constant rate of climb there without losing any rate of climb. This will of course be different if you were to fly the normally aspirated version of the plane that I showed you initially at the beginning of the video. So if you were to fly the normally aspirated version, then of course you would be losing manifold pressure as your altitude increases and you have to lean the airplane during climb. So both of the two aircraft that come with this package provide quite a different experience, and that is something that I do really appreciate. Okay, so since we've reached our cruising altitude, let's reduce power a little bit to some settings that we would typically find in cruise. So if you want to go really fast, 35 inches. If you want to go at a decent speed, use something in the region of around 30 inches manifold here. And I'll give this a little moment to stabilize, and then let's see how fast we actually are in terms of true airspeed. So let's also select RNAV on the HSI, on the DME over here. Now we're basically seeing the distance towards the reporting point that we've generated. And you can already see we're doing 260 knots ground speed over here. But let's give the speed a little bit of time to stabilize. And in the meantime, I'm going to show you some of the features of the EDM 760 engine monitor. So, the engine monitor is basically there in order to help us stabilize our engine RPMs and optimize the usage of fuel in order to provide us the greatest possible range. So it's basically a leaning computer. So let's go ahead and actually lean a little bit with it. We have just about set our cruise power, and as I told you, the turbocharger did a great job of just keeping the manifold pressure stable. But now let's actually start leaning in order to save a little bit of fuel there. So, first of all, we're going to pre-lean. And this basically means we're going to reduce the mixture until we see the EGT, or the cylinder head temperature over here, first go back. First rise and then go back again. So let's start doing that. So, the cylinder head temperature is rising. And now it's reached its peak. So now we basically return the thrust levers again to the position that is roughly halfway forward of what we just leaned off. Now let's click the lean find button, and now we're going to lean ridge of peak. For those of you who have the analog Bonanza, this is going to be quite familiar to you already. So now we basically do the same again until we get the leanest indication. Note that I'm doing it on both engines simultaneously here, but here we go, peak EGT on the left engine and on the right engine. So now, looking at the computer, we are going to increase our power again until we see the number up here, which basically is our cylinder head temperature, until we see that go down to about -50. So let's go ahead and do that. Was a bit fast, maybe. Okay, so with the number in the region of around -50, we now have leaned the airplane to the optimum power. So if we press the step button, then we can actually get it to show us the horsepowers that our engines are currently producing, which is around about 214 at the power setting that we have just set. So now, that is maximum power. However, in practical terms, we are usually more interested in sacrificing a bit of the power in order to get our best economy. So let's do that. So we press lean find again, and now we would hold both buttons at the same time. There is a hidden click spot in the middle. If you hold that for a bit, you can simulate holding both buttons. So now we are going to lean off peak. So now we are reducing our mixture once again until we pretty much get the last peak indication that we just about had here on our left engine, and we should have it on the right engine now as well. Okay, so as you can see, I'm barely changing the mixture there in order to achieve those indications. But now we have a fuel flow of around 18 gallons per hour on both engines, as you can see here on the main gauges as well. So that is our most economic leaning position that we have for those engines at this power setting. So let's see how fast we actually are now. And we can do that without the help of any fancy GPS. So first of all, look at the outside temperature, which is currently -23 degrees centigrade down here. And now look at the airspeed indicator. So up here, if we now take the inner scale, which represents the altitude, and the outer scale, which is the temperature in degrees centigrade, and now we rotate the 20 position onto the -23 position, which is somewhere like this, we can see that we're actually doing 240 knots of true airspeed at the moment. So that is quite amazing for a small airplane like this one. Alright, so that is pretty much everything I can show you up here at higher altitude. So let's go ahead and start our descent towards Mannheim in order to do some traffic patterns, and thereafter we are going to go back to Egelsbach where we are going to do an engine failure, but we are going to do that VFR. So we are now 10 miles away from our target waypoint, and let's see currently where the reporting point is. Pretty much straight behind, okay. So let's go ahead and start our descent. We'll initially go down to flight level 100 and then we'll do a further descent. There are two ways you can do this. This is the easy one. You pull the little knob, it gets you the target vertical speed. Put it down to 1,000 feet a minute, and the plane descends at 1,000 feet a minute. You can, however, also take it out of the vertical speed mode. Now you can basically use the up and down knob on the autopilot there in order to set a target pitch of the plane. So both modes are doing quite a good job. First, let's actually put it in a vertical speed. Give me 2,000 feet a minute, and then we can get a cabin descending as well. So once we start our descent, we've got to get the cabin down to the destination field altitude, which in our case is going to be in the region of somewhere around 300 feet from Mannheim. So something like that. A little bit of easy mathematics here in order to manage our cabin. 2,000 feet a minute from 20,000 feet means we are going to need 10 minutes for the descent. The cabin is at 9,000 feet, so it's got to descend by around 8,500. So cabin rate of descent in the region of around 1,000 feet a minute here should do well. Note that with this, I'm basically showing you the maximum descent performance that this airplane can achieve. You could, of course, simply reduce thrust and make the plane descend faster, but if you did that and you would then make the cabin descend at an according rate, it would really start to hurt on your ears. So this is about the maximum that we can do here, and we just have to use a little bit of throttle control in order to keep our airplane going where we indeed want it to go. Okay, let's start a right turn, heading towards that reporting point that we have previously set up in the ANAF computer. You are supposed to descend the plane around 185 knots. Now, personally, I like to go a bit faster, but seeing that we are definitely going to experience a little bit of turbulence in the weather that we're about to fly through, we might indeed want to get the speed below the amber band. So note as well how the cabin temperature has reduced a bit again because we never touched it, or rather because we never touched the air increase in the flight here. So cabin temperatures, as said, are dependent on the outside temperatures in this plane as well. Okay, the speed is nice and low. One more thing that I can demonstrate to you here is the external tanks of the airplane. We can see that we've used up around about 1/8 of the total fuel from the main tank, but we didn't use any fuel from the tip tanks. So if we go ahead now and switch the fuel boost pumps on, and then switch the tip tank transfer pumps on, we can see the green lights illuminating here, and that's basically indicating us that fuel is now being transferred from the tip tanks towards the main tanks of the plane. Also, another quick word here on the aircraft's ANAF computer. Now, in the real plane, if you selected your HSI source towards ANAF, you could use the nav mode in order to track the HSI. Now, in the simulator that does unfortunately not work, so Microsoft got some issues there, which do prevent Black Square to simulate this at the moment. So we've just got to use heading select mode in order to follow our ANAF computer data. Okay, let's go down to 5,000 feet. Actually, let's go down all the way to 3,000 feet. And that should hopefully put us below the clouds so that we can fly our visual approach. Another idea may of course be just to fly an RNAV approach, or sorry, not an RNAV approach, with a KNS-81. Back in the day, in the 80s, where these computers have been used, they actually flew RNAV approaches often, but nowadays that is not allowed anymore. But we could of course go to fly a localizer-only approach over at Mannheim, which might provide for some interesting maneuvering. So for the purpose of today's video, however, I am going to fly the VFR maneuver. So I'm sure that at one point there will be a live stream where I'm going to demonstrate the entire IFR capabilities of this airplane. But since I figure that most of you are not going to actually fly the plane IFR using the RNAV computer, I will do that in a separate video where I'm going to use the GTN 750 that I'm sure most of you are actually going to use. So we've got 7 minutes to run to the reporting point, and we've got to reach 2,000 feet at that point, which means we need to lose 8,000 feet. Divided by 6 minutes gives me something in the region of around 1,700 feet a minute. Let's check the cabin. That's still descending nicely, passing 5,000 right now. Doing 1,000 feet a minute. Perfect. So a bit more power and going through the clouds. Let's put the anti-ice on. Temperature is just around 0, so we are about entering that area where we could actually encounter a little bit of icing. But looking at the wings, they do seem clear at the moment. Yep. Do note that even though you are flying through possible icing conditions, there is not always actually icing inside the clouds. So what we're seeing right now actually is quite realistic, that we must not necessarily get icing just because we're flying through possible icing conditions. Okay then, 6,000 feet a run, 5 minutes, so let's do something around 1,200 feet a minute, increase the power in order to maintain our speed. As said, 185 is the recommended descent speed in the Baron. And the recommended approach speed that we'll need later on is going to vary a little bit depending on the gross weight of the airplane. So, looking at the different numbers, something in the region of around 90 knots usually goes quite well, but if you are heavy, like we are today, seeing that we have almost a full complement of fuel still on board, then we might want to use a little bit more, like 95 knots. Small explanation there as well, as we are flying along. Those of you who've previously flown the Bonanza will have noticed that there are 2 more indications now on the airspeed indicator. One is the blue line, one is the red line. Now, those are actually something you would typically find inside multi-engine aircraft, and the blue line basically is the best single-engine rate of climb speed, while the red line indicates the minimum control speed in the air. So, what does that mean? Basically, if you have an engine failure, you want to fly the blue line for any climbs, as you're going to get the best performance, and don't go below the red line, because at that point you will not be able to maintain directional control of the airplane with the operative engine set to maximum thrust. Okay, we are VMC, so at this point we can basically cancel our IFR. Let's return to squawk VFR over there, 7,000. And also note the cabin temperature is increasing quite a bit right now. So what I'm actually going to do, on the ground is rather warm, so I've just turned the heaters off, and you could hear the heaters going off as well. And since we're flying VFR, let's put the landing lights and the taxi light on, so that we are easier visible for other aircraft. So we can slowly see Mannheim coming up over there, so let's start preparing for the approach that we are about to fly. And for that we can have a look into the AIP. And thankfully the German Air Traffic Control Services have made the AIP available online for free now, so we can actually get the current real-life approach charts for our flight. So, as we're descending down, keep a quick eye on our cabin altitude, which is now at 2,000 feet, so you don't want to descend below the actual cabin altitude. Otherwise, just go ahead and flick the cabin pressurization switch to dump, and then your cabin is going to equalize with the current actual conditions. So, defroster off, cabin heat is off. Okay, also the fuel transfer is going nicely. We can see the tip tank fuel slowly reducing, while the main tank is increasing again. Okay, 2 more minutes to the reporting point, so let's have a quick look into the approach charts for Mannheim. So this is what we've got. Checking out the AIP. We want the AIP VFR, aerodromes, Mike, and then we're looking for Mannheim City Airport. Here it is. So that's the approach chart, and this is the point that we have tuned in our RNAV computer. So we're currently heading here towards Kilo, which is along the highway, and then we'll enter the control zone on the right side of the highway, all the way into the final approach for runway 27. There is no maximum altitude defined, but seeing that the control zone is 2,000 feet high, we are going to stay below 2,000 on that approach, and finally we are going to fly left-hand traffic patterns. Alright, so that's the preparation for the approach pretty much completed. Let's descend the plane down to 1,800 feet. 2.6 miles prior to the reporting point, so if we check this, we can actually see the highway over there, we can see the crossing highway over there, so that's basically our definition of the Kilo point. Okay, enough autopilot flying, let's actually get that autopilot out and see how the plane handles manually. The runway over in Mannheim is a 27, so I'm going to pre-select that at the course. HSI source back to nav1. And here we go, the intersection of the two highways we can see in front of us is reporting point Kilo. We're going down to 2,000 feet, so we can enter the control zone in a moment. It is a little bit rainy, I'm wondering what the visibilities are going to be inside there, but let's just hope that we will be able to see something. Entering the control zone, let's start reducing our airspeed. I found that at 15 inches the plane usually flies quite nicely. At typical pattern speed, so speed is going down. We can see that little white marker up here, that is our approach flap speed limit, and then we got the landing flap speed limit over here, so that's the two things that we want to take care of. Preparing for the approach, the mixture is going to go full rich again. The cabin altitude is pretty much down, so let's dump this down now, and the main tanks are pretty much full again, so I'm going to turn off the tip tanks and the fuel pumps. Okay, nice. Then Mannheim Airport should start coming into view any moment now. And I believe that is actually it over there. Let's just keep following that highway and hope that the visibility is not going to be too bad inside those rain showers. You can see speed has reduced nicely, and as we are going to enter the final directly, let's extend the approach flaps. So, I believe that's our airport over there. And call flaps open. Yeah, we can see the approach lights over there. Nice. Okay, gear down. Landing flaps. Are out, and then let's turn final. 100 knots is a good approach speed. I'm going to turn the prop levers up to a max just before we overfly the runway threshold so that we don't do too much noise. 95 knots, nice. And like that, we can enter the final. Okay, quickly going to pre-select the pattern altitude of 1300. And that looks all good. Okay, going below the pappies intentionally here. And we're down. Not the prettiest landing, I have to say. That was just a little bit turbulent there. Okay. Power set, props full forward, rotate. Positive rate, gear up. Normally it's easier to land this. That was just a little bit crosswind there. Okay, 400 AGL, reduce power, and then let's turn up wind. Also taking off a little bit of manifold pressure as we're about to reach our pattern altitude. Visibility isn't great, but is still within the VFR limit, so that is quite fine for me. But we shouldn't exceed 30 degrees of bank here. Okay, we can see our airport down there. Certainly not perfect visibility over here, but that makes flying a bit more interesting, doesn't it? And here we go. Okay, beam the landing runway threshold, so let's start reducing our speed once again. We are within the region where we can use approach flaps, so let's use them in order to help decelerating the airplane. Gear down. And we can start a slow base turn here. Basically we want to stay just on the other side of the highway over here and not overfly the residential areas. So this looks quite good. Okay, landing flaps. So we're going to do this touch and go, and then we'll fly the airplane back towards Egelsbach, and on the way we are going to demonstrate an engine failure. Okay, so here we are, final turn. So, nicely on puppies. Speed 95 looks good. So, let's do it better this time. Okay, throttle to idle. Down we go. Flare a bit. Okay, that much about let's do it better this time. It's not my day today. Normally this plane lands pretty well. Okay, power set, rotate. And gear up. Okay, we're going to leave the controls on northbound via the River Rhine. Visibility in that direction looks generally okay. So, climb thrust, we can go up to 1800 feet. Provided the clouds actually allow us to do so. But that seems about fine. Okay, let's stay here. Alright, so once again, I'm going to use the high speed to get out of the control zone over here. Thereafter, we'll reduce to a little bit lower speed once again in order to demonstrate the engine failure. So we can just give it a little bit of temporary leaning over here, like this, and we actually don't need most of those anti-icing stuff here. Next up, we'll climb 3,200 feet. That's going to keep us below the controlled airspace of Frankfurt, which extends to 3,500 here, until we pretty much reach the read VOR that we've tuned to active on the VOR receivers up here. Okay, here we go. So let's continue our climb. Looking for 3,200, provided the clouds allow this. But I want a little bit of altitude when I'm demonstrating the engine failure to you. And cowl flaps closed, as you can see, cylinder temperatures are looking very good. Okay, this looks quite good. So let's reduce power a bit. We'll go 20 and 20 here. So there we go. Cruise power is set. So let's now have a look into the non-normal checklists that we can find. And we can see we've got a lot of them, like engine fire ground, engine failure ground roll, engine failure takeoff, and so on. But the one we want to have a look at right now is the engine failure in-flight checklist. So here's what to do. Airspeed 115 knots, that is going to be the speed for the best glide. Inoperative engine identify, inoperative engine throttle closed, inoperative engine propeller feather, fuel selector, inop engine crossfeed. And that's basically securing the engine. After that we start to try to restart it. Now, before I'm actually going to attempt the real engine failure here, let's very quickly go ahead and check out some of the engine simulations. And the way I'm going to do this is I'm just going to close the mixture for the number 2 engine. Or let's do it for the number 1 engine, actually. We'll do number 2 later. So, as I'm about to do that, the engine's basically going to shut down, as it does right now. That also means we need a bit more thrust on the number 2. Now we can see we've got that little red light blinking up there. This is the low thrust indicator for the left engine. And the reason we've got this indicator is because it might not be so easy to determine which engine has failed when we're looking at the engine indications. So we still have some manifold pressure, we still have some RPMs, all the fuel flow has reduced greatly. So, as you can see, it might not be that easy to identify which engine has failed, and therefore the low thrust alert light is blinking. But here's something I want to show you. Due to the engine still windmilling at the moment, if I'm just going to increase the mixture once again, you can see the engine immediately restarting. Okay, nice. So with that, let's just about stay at the present position, because now I want to do a real engine failure. So that's our props reduced again. So let's go into the menu now, and I want to go to scheduled failure, detailed, left engine failure. I'm going to arm it in a moment. We'll do it between 1 minute and 2 minutes. And actually, you know what? I said earlier I wanted to fail the right engine, so let's do that. So, right engine. Between 1 and 2 minutes. Yes. Okay, so now I've got to wait a minute or two, but we are going to use that time in order to have a look at what we're going to do with the checklist then. Because this is how the checklist continues. Basically, we are going to secure the engine, and thereafter we'll try to restart it. So inert magnetos, check both, inert boost pump, high, inert mixture, rich, then lean, that is basically priming the engine again. And then inert engine starter engage, inert engine if no restart, boost pump off, mixture rich. So this is the first restart attempt here, where we are basically trying the cold start procedure. The reason we're using the cold start procedure is because the air might quickly cool the engine down. So if the cold start procedure doesn't work, then here's what we're gonna do next. Next up, fuel boost pump off, mixture full rich, magnetos both, starter engage. So if we're doing that, we are basically trying the flooded engine start procedure. And if that doesn't work, we're going to shut the engine down, secure it, and then we are going to return to the nearest airport. Which in our case, by the way, is going to be Egelsbach. We will be returning there. Alright, so that is pretty much how we are going to handle the engine failure when it then eventually happens. So let's recap the situation that we're currently in. I'm just about holding south of lead VOR at a place where we can still use sufficient altitude, because beam the VOR, we have the controlled airspace of Frankfurt, so we've got to descend there, but I want to keep a little bit of altitude here before we are going to fail an engine. Apart from that, we are pretty much in a normal cruising configuration, so our engines are set down to a low power setting, like you would use it when you just want to, you know, enjoy flight. And we're doing a nice airspeed, 140 knots, and our airplane is pretty much in a cruising configuration. Okay, so engine failure. Okay then, memory items. Thrust lever. Confirm the failed engine. Okay, we've got a low thrust light on the number 2 engine, and looking at this, we have reduced manifold pressure. We do have some RPMs, but less than commanded, and 0 fuel flow, so it is a failure of engine number 2. Okay, memory items. Engine number 2, thrust lever idle. Engine number 2 confirmed. Prop lever, feather. And engine number 2 mixture cut off. Okay. So let's quickly increase thrust on the number 1 so that we don't start losing it. Okay, that's the prop of the number 2 engine feathered over there. You can see it's still moving a little bit in the wind stream, but apart from that, prop is feathered. Okay, so engine failure in-flight non-normal checklist. Airspeed 115 knots. Well, we don't need to do that. We have sufficient altitude and performance at the moment. Inoperative engine identify. So we've got the low thrust light blinking up there. We do have manifold pressure, we have 0 RPMs, we have 0 fuel flow, and 0 oil pressure. The engine number 2 is inoperative. Okay, inop engine throttle close, number 2 closed. Inop engine propeller feathered, confirmed feathered. Fuel selector inop engine cross feed, that's the right side. So that's the fuel selector there, the cross feed. Then, inop engine magnetos, check both, that's number 2 side, both. Inop engine boost pump high. Then inop engine mixture, rich, then lean. Okay, rich, then lean. Inop engine starter engage. Okay, we tried it, but it's not working. Okay, let's continue that checklist. Inop engine, if no restart, inop engine boost pump off. off. In-up engine mixture full rich. Full rich. In-up engine magnetos check both. Both. Okay, in-up engine starter engage. Let's try to view that. Okay, if no restart, no, there is no restart here. Okay, in-up engine, if no restart, nearest airport select. We said earlier already that we are going to return towards Egelsbach Airport. And we can easily find that. We are outbound read viewer already. Down there is the highway. Let's return to that. Okay, so in-up engine fuel selector off. That's the in-up engine fuel selector off. In-up engine boost pump off. Off. In-up engine magnetos off. Right side confirmed. Off. In-up engine alternator off. Right side confirmed. Off. Cal flaps closed. Closed. Alternator load 80 amps max. We're at 75 at the moment, so we are good. Okay. So we've got to descend 1,300 feet right now, so that we don't fly through the controlled airspace of Frankfurt there. Okay, and that is basically the engine failure case completed there. So let's return to Egelsbach Airport. Oh, don't climb. Keep descending. So if we look at the approach chart, then Egelsbach is basically getting a little bit to the left of us. We can get rid of that chart and then over to the left. And is that Egelsbach? No, that doesn't look like it. But just to be on the safe side, where are we from read viewer? That does definitely not look like Egelsbach up there. I don't think that's it. No. Egelsbach should still be on the right of us, but let's try and find it. Eventually we can help ourselves with a little cheat there. And let's just search for Frankfurt Main VOR, which is 14.2. This is, by the way, easily how these things might go when you are not using any GPS system or the likes. This is just, you know, how people have flown earlier on. What I'm currently confused about is this little airport over there. That doesn't really seem to fit the scene. But we are still about using the read VOR here. 6 miles off, so we've got to turn to the right hand side here, and then we're basically looking onto a radial of 021 from read VOR, which is going to lead us straight towards Egelsbach Point Delta and not into the ground. So let's pre-select that 021, so we need to go a bit more to the right hand side, and we can actually see runway 18 of Frankfurt Main Airport up there, I believe, so that would make it easy to navigate and find our way around. Not my best piece of navigation right now, but then again, we're flying with an engine failed and trying to do the job of more than one pilot at the same time here. Normally, what I would have done in real life in this situation, I would have simply asked air traffic control for radar vectors towards Egelsbach while maintaining VMC at the same time. So that's the reason why navigating and doing everything at the same time can be a little bit annoying. But we should be almost there. Yep. I'm basically following this heading until I can find the highway that we flew out on, which should basically more or less be on the radial from that VOR. Something I always find a little bit, let's call it suboptimal, is when you are flying a multi-engine general aviation aircraft, the visibility outside is rather restricted compared to the single-engine equivalents. So, as you can see, we've got the engine in front of us over here, we've got the nose in front of us over there, so that makes it a little bit difficult, but we've made it. Over there is the airport, so we can start our approach now. Okay, joining the downwind, let's start reducing our speed a little bit. And we can get the approach flaps out. Lights are on already. Landing gear down. Patron altitude 1300 feet. Over there is the airport. So at 1300 on speed, nice. Let's start the base turn. Here we go, looking good. Okay, propson can definitely go off, we don't need that. Then, starting our descent. Landing flaps down. Reducing thrust slightly, we're looking for 100 knots approach speed. Don't be surprised if we see 2 reds on the parapets. This is designed for a 4-degree approach path, but we are not going to follow that. We will fly an approximately 3-degree path here. Okay, here we go. Nicely established. $100 knots, looking good. This is pretty much what we are looking for here. Tiny bit more thrust, maybe even, so that we clear those trees in front of the runway. Okay, that was the trees. Thrust idle, flare, and here we are. Welcome to Egelsbach. I'll let it roll to the taxiway, and then we'll take that and taxi back to the apron. Single engine taxi in this plane is not much of a problem, you can do that. I actually find it quite a bit nicer than the 2-engine taxi, because the plane just got so much power. So that's the runway vacated. Let's just stop it here for a second in order to secure everything after landing. Here we go. So, flaps up, landing lights off, strobe lights off, nav lights off, and pitot heat off. Cabin is depressurized as well, and transponder into mode alpha. Weather radar can go standby, and with that, we can start our taxi in on a single engine. Number 2 side is still off. We will of course need a little bit more power than normal, but once it's rolling, it should be rolling nicely. Here we go. As you can see, directional control, no problem at all, even at these stronger power settings. This is, by the way, pretty close to what I'm used to from flying multi-engine piston aircraft in real life as well. So we can really get the plane rolling, and once it's rolling, you just leave the other engine idle first, and you just don't have any directional control problem with these. There is a common misconception among flight simmers that it would be, you know, hard to control an airplane like that, but it is absolutely not at all. Okay, let's take that parking spot up here. And here we are. Okay, that's the parking brake set. Avionic master can go off. Pretty much all the switches except the beacon are off. Okay, shut down. No thanks, GSX, we don't need you. Okay, the engine has come to a standstill. Alternator off, battery switch off. And with that, welcome to the Analog Baron. So, what is my feedback after this flight then? Well, it is an absolute joy to fly. You guys know that I love these small aircraft as long as they are simulated decently, and there are not a lot of well-simulated aircraft available that are simulated decently. So, what's my feedback then? Well, I absolutely love it. I am not going to make a statement like this gotta be the best multi-engine aircraft, because there is always the Milvis Blackbird C310 out, which is a very good airplane as well, and I don't want to make a direct comparison between the two. So let's have a look into the features of the Black Square Analog Baron. Systems. There is nothing to complain about in terms of the system. The thing flies, or the thing handles exactly like it should. The systems all work, the circuit breakers all work, and I couldn't find anything that was not simulated here. So, flight model. The airplane flies very nicely, and it got all the challenges that we talked about earlier in this review while flying the plane, so there is not a lot more to add there. The thing flies very nicely. I do apologize for my 2 landings over at Mannheim. I don't know why those have been worse than pretty much any other landing I've done with this plane so far, but normally this flies and lands very nicely. You've just got to make sure that you're on speed when you're crossing the threshold, and then you can put it right down where you want it to be. Apart from that, it's got some superb performance, and it's flying exactly what we would expect it to fly, and that is really all that counts. In terms of performance, as in frames per second, the plane is working really well on my system, so I didn't suffer any performance decrease. I do need to say at this point that if there have been any greater stutters inside the video, then my recording software is sometimes doing that without those things being there in my actual simulator. So if you've seen any major stutters inside this video, then that's been due to the recording software, not due to the airplane itself. In my simulator, everything ran 100% smooth. Okay, so the final point here is the value for money, and that is where the Analog Baron really shines. The guys at Black Square took some great approach to take default Microsoft Flight Simulator aircraft and bring them to study level by enhancing the panels and rebuilding all the systems. This basically means they could save the money that it would normally take for rebuilding the outside model, and it means they can save some money on the sounds. However, they did add quite some custom sounds, like for example from the cabin heater as well, which is something I really appreciate. So overall, great value for money here. The plane is going to release at about 30 euros, and owners of the Black Square Bonanza will be able to get 25% of the Baron, since they are rather similar aircraft, and the Baron is basically the multi-engine version of the Bonanza. However, with all its particular systems modeled. With that, I would like to thank you very much for flying with me, and hope that you have enjoyed this review of the Baron. I can very much recommend it. It will be available from Just Flight from the 23rd of March onwards, so by the time you're watching this, it's probably going to be released already. So thank you very much for your attention, and as always, like, comment and subscribe, as it does really help out the channel. And if you really like what I'm doing, I would appreciate a small donation through the Buy Me Coffee link in the video description below, or by becoming a channel member, which is going to give you exclusive early access to new videos before they are released to anyone else, and in first class membership, even the ability to request your own videos. For now, thank you very much for watching, and I'm looking forward to welcome you all again on the next one.